Hey guys, today we are going to be talking about Unit 4, Lesson 2, and it's called Function Notation, which is basically just a fancy way of writing what happens in a graph or an equation or in a function. Okay, so take a look at these three graphs. These are about the dog being tied to the post, and then a man walks away, and the dog moves away from the post or comes back. These are motion graphs, right? We can see that over a certain number of seconds, the dog is a certain distance from the post. Okay, and these graphs are of 3 different days, day 1, day 2, and day 3. We're going to use these to show you how to write in function notation. Okay, so what is function notation? Well, function notation is basically just a machine, right? It's like an input-output machine. So I'm going to put an input into my function machine, and it's going to give me out a number. And in this case, this is how you write it. It looks like this. We say f of t equals something else, right? Which means we're going to put a number, t, into our function, say like 60. We'll put in 60, right? So I'm going to put 60 in here, all right? So we're going to call it 60 seconds because of our graph is in seconds. And it's going to output a certain number, right? Output a certain number. In this case, the number is 4, all right? Now, this is kind of like your soda pop machine, right? Or your Coke machine where you push a button on the vending machine and it gives you something out on the other side. Okay, we're going to put in a number and it's going to give us something else, right? Okay, so let's analyze what this might actually mean with our graphs, okay? So we're going to call each one of our distance graphs, we're going to call it, for day 1, we're going to call that function f. Day 2 is function g, and day 3 is function h. Now, if I go back up here to the graphs, that means that this one is going to be function f, this one is going to be function g, and day 3 is going to be function h. Okay, I can analyze what's happening on this graph using this table, okay? Now, let's practice writing in function notation, okay? This basically says the distance from the post 60 seconds after the owner left. Well, if I'm going to see what that distance is on each different day, I can say, well, at f of 60, so this basically means after 60 seconds on the first day, the dog was a certain distance away. Since we're calling the second graph function g, or day 2 is the g function, we're going to go g of 60. And day 3, that was function h, so we're going to call that h of 60. And these all equal a certain distance, right? A different distance. If you look at the graph, it's pretty clear at 60 seconds, they're all kind of at the same spot. They're all at 4 feet. So each one of these is actually going to equal 4, which is just a coincidence in this case. Okay, so same with this last one right here. All right, now we can use this to express like what these things mean on these graphs, right? We don't just have to put like a point in there or make a table or an equation. We can actually use function notation to explain it instead. All right, so let's look at some values. So for instance, what does f of 15 mean in this case? Well, f means day 1, right? So we're going to say day 1 at 15 seconds, the dog was, I don't know how far away he was, not that far. Let's check. The dog was about 3 feet. So we'll go back here. We'll say 3 feet away from the post. That's what f of 15 means. It means the dog was 3 feet away at 15 seconds in on the first day. Okay, now let's look at like something in reverse. Okay, so let's go. Oh, this is interesting. All right, so let's look at this one down here. G of, oh, not that one. Sorry, this one. F of t equals 5. So now we're still looking at day 1 because this is function f. So we're looking at the day 1 graph. All right, and this is saying the dog was 5 feet away. So we can say, well, what time was the dog 5 feet away? Let's go back to our graph. And it says day 1, let's see, at 5 feet, looks like, oh, right here, so about 50 seconds.